All right, welcome. We're going to talk about tangent today. Tangent. Remember, tangent is sine over cosine, which is just y over x. Remember, we have x and y for coordinates on our unit circle here. Unit circle, whatever. You know what I mean? Unit circle. Okay, so a couple of things. Let's look at this. We have tangent is 0 whenever sine x equals 0. Well, why is that? First, let's find where sine is 0. So sine would be 0 right here and right here because we have x and y here. X and y. And remember, tangent is y over x equals 0 over 1. Oh, that's 0. And then this one here, we have, tangent is y over x, which equals 0 over negative 1. Oh, still 0. Next thing is tangent is undefined whenever cosine is 0. Oh, wonder. Oh, okay. Well, look at this. Look, watch. So, what happened here? Circle. There you go. Come back, circle. Okay. So, here, x and y over x are tangent. So, we have 1 over... We can't do that. That's illegal. No. Sad face. Same thing with this. Oh, look at that. X, y. We'll have negative 1 over 0. Uh-oh. No. It's undefined. You can't do that. Now, take this property and look at our equation here. So if you see here, the general tangent function looks pretty much like the sinusoidal functions we've been looking at so far. The only difference is now we have tangent. So here, D, that is our midline. They call it principal axis. That's two big words for me. I just say midline. Midline, because the word mid is in it. We know that's the middle line. It cuts it in half horizontally. Just say midline. Period. So normally you're like, wait. Why is this pi over b? Isn't it supposed to be 2 pi over b? Well, look at our graph here. Look at my graph. Okay. So from here to here would be one full cycle of tangent. So one full cycle of tangent for the general tangent function is over 0 to pi. So that's why you have pi over b. For sine and cosine, it's over 2 pi. For tangent, it's just pi. And then now the amplitude of the function is undefined. Well, why is that? Well, look at this. Look. So the amplitude is supposed to be that distance from the midline to the maximum or the midline to the minimum. Well, look at this. Here's a midline here. The distance from the midline to the maximum, oh wait, it goes on forever. Same thing here. Midline, minimum, oh wait, it goes on forever. So amplitude, we consider it undefined. But we can still have a number here for A. It's just, as we're changing that number, it's either going to stretch our graph way up like that, like this, or make it wider like that. Let me just give you some graphical examples of what I've been talking about. So, if you look here, this is graph of sine. Sine is 0, at 0, and pi, and 2 pi, and it continues in that pattern. Oh my God, Amber. Oh my God. Well, look at this. Look. Remember we said tangent equals 0 when sine equals 0. Well, again, sine was 0 here, and here, and continues so on. Well, look at that. The green graph, that's tangent. So tangent's also 0 here. Same spots. Pretty simple. Pretty nifty. Well, now let's look at cosine. All right, so this is graph of cosine. Cos. Cosine is 0 here, and here. Now let's look at the tangent function over the cosine function. Ooh. Again, cosine's 0 here, and here. But look, that's where our asymptotes are. Our asymptotes are for the graph of tangent, because tangent is undefined there. Tangent will never touch that value. And let me just give you a quick example of a problem you might get. So here we have P and Q. We got to find those two. Oh, look at that. We know that's the midline. Midline. Well, look, I have a midline right here. And it goes through, right here, y equals 1. So I'm going to say, okay, so far I have y equals tangent. Don't know P yet. T plus 1, because it went up 1. Now let's look at this. Remember, here, this represents the number of cycles we have. I'm looking at this graph here. So normally, you know, for cosine and sine, we said the period was over 2 pi. All right, so the period of tangent is over pi, which is why we say pi over b, or the number of cycles here, equals our period. So even notice in our graph here, we have one full cycle between 0 and 2 pi instead of pi. So our period here is actually 2 pi. That is our period, equals, and we're still going with this because to find the period of tangent, it's pi over b, pi over, instead of b here, we have p. We got to find p. So, okay, well, if we just do our algebra, we know that we can say, oh, p equals pi over 2 pi. You know, just switch the two sides. And then I'll end up with, oh, 1/2. So p equals 1/2. So I'll put 1/2 here. And if you graph that, you'll see that you'll get this graph. And you're probably saying, okay, what the heck does that even mean? Well, watch this. I'm going to show you really quick. What that means is it says we only have half of a cycle that's shown here. Now watch this. So normally for tangent, we're looking at 0 to pi. So normal tangent graph, the general tangent graph, from 0 to pi, we're going to have a full cycle, but we don't. If you notice here, we only have half of a cycle here. This other half is over here. It goes from 0 to 2 pi. So that's what that means. So from 0 to pi, we only have half a cycle. That's what that means.